Good morning. Today we'll delve into the domain name system, often referred to as DNS, which serves as the backbone of the Internet. I'll begin with a brief introduction to set the stage, then we'll dive into the core topics. We'll start by exploring the concepts of systems in general. Next, we'll define the domain name system, or DNS, and its significance. We'll examine how the DNS fits into the larger framework of systems and networks, and we'll explore the broader context of how DNS and the Internet are intricately connected. Lastly, we'll delve into the crucial topic of security concerns and implications related to the domain name system. So, a little bit about me. I'm Tyler Dibble, and today we're diving into the fascinating world of DNS and its crucial role in cybersecurity. I'm currently a full-time student at Boise State University's Cybersecurity Operations and Resilience program. When I'm not immersed in my studies, I find passion in activities like weightlifting, hiking, snowboarding, and exploring new places with my wife. My deep curiosity about how our world operates is what drives my interest in computers and cybersecurity. So, what exactly constitutes a system? In essence, a system is an interconnected set of elements that is coherently organized in a way that achieves something. Now, while this definition may seem broad initially, let's dissect it further to gain a more precise understanding. At its core, a system consists of three fundamental components: elements, interconnection, and functionality. Systems are composed of various elements that are intricately connected together. These elements collaborate in a synchronized manner, much like the organs in our bodies. The interconnected elements within a system work together to perform specific functions or fulfill a defined purpose. Think of your body, where organs collaborate seamlessly to sustain your health and well-being. Without a crucial element, the system falls apart entirely, such as your heart, your brain. Furthermore, systems are outcome-oriented. Crucially, systems are designed with a clear outcome in mind, whether it's maintaining your body's equilibrium or facilitating a specific task in the digital realm. Systems are engineered to achieve a particular goal. Now that we have a grasp of what a system is, let's delve into the domain name system, or DNS, and its significance. Picture DNS as your digital librarian, the helpful guide who simplifies your search for a book. Imagine having to remember the serial number or ISBN of each book you want to find and read. It would be quite challenging and tedious. Fortunately, DNS steps in as the friendly librarian, making your life easier. In the digital realm, DNS plays a vital role in how computers communicate over the Internet. Every time you enter a web address into your browser search bar, you're essentially relying on DNS. Its primary function is to map web addresses, often referred to as URLs, to their corresponding IP addresses. This mapping is crucial because web servers exclusively communicate using IP addresses. Without DNS, the Internet as we know it would simply not function. So, how does DNS actually work? This is a step-by-step process. It takes user input, and it all begins where a user enters, for example, example.com into a web browser's address bar. That query is sent to a resolver. It travels through the Internet and reaches the DNS recursive resolver, which is a crucial component in the process. The resolver initiates a query to a DNS root name server, the Internet's starting point for DNS inquiries. The root server responds by directing the resolver to the appropriate top-level domain, or TLD, DNS server, for instance like .com or .net, which stores domain information. The resolver then reaches out to the TLD server, such as .com, with the request for example.com. The TLD server replies with the IP address of example.com's name server, which holds detailed domain information. The recursive resolver, armed with the name server's IP, queries the domain's name server directly. The name server responds by providing the IP address for example.com. Armed with the IP address, the recursive resolver communicates it back to the web browser which initially requested it. The result of this is seamless web browsing. With the IP address in hand, the browser can now proceed. The browser makes an HTTP request to the retrieved IP address. The server located at the IP address sends back the web page content, allowing it to be rendered in the browser. It's worth noting that all these servers and elements in the DNS ecosystem are interconnected. They work collaboratively to facilitate IP resolution, thereby ensuring our online browsing experience remains seamless and efficient. At this point, it's evident that DNS is indispensable for our internet experience. It's the unsung hero that makes navigating the vast online landscape seamless and user-friendly. Let's summarize the key reasons why we rely on DNS. Because of its user-friendly navigation, DNS enables us to access websites using easy-to-remember and human-readable domain names. It also provides load balancing. DNS distributes traffic among multiple servers, boosting website performance, reliability, ensuring a smooth browsing experience. It also provides redundancy and fault tolerance. By allowing multiple DNS servers for the same domain, the DNS ensures website availability even if some servers encounter issues. It also enables global reach. DNS is the glue that connects us to websites across the globe, making the internet a global village. Now, if the DNS was absent for some reason, or if we did not have it, let's consider a hypothetical scenario without DNS. So, picture this. Users would be required, without DNS, to memorize and manually enter IP addresses, rendering the internet virtually unusable for the average person. The user-friendly navigation properties that DNS provides, think of street signs, would vanish entirely. There's a risk of IP addresses becoming centralized, leading to vulnerabilities and single points of failure, which could disrupt the entire internet. On top of usability issues, security concerns would arise. DNSSEC, or DNS security extensions, was developed to safeguard against threats like DNS cache poisoning, ensuring the integrity of our online interactions. In essence, DNS isn't just a convenience. It's the bedrock of our online world. Its absence would drastically alter the way we access information and interact with the internet, underscoring its critical role in maintaining the functionality, usability, and security of the digital realm. Next, I'll cover a few ways DNS can be exploited. DNS spoofing, or DNS cache poisoning, is where attackers manipulate DNS responses to redirect users to malicious websites. This is done by injecting false information into DNS caches. This can lead to phishing attacks and malware distribution. Next is DNS tunneling. Threat actors use DNS to create covert communication channels, allowing data exfiltration or command and control traffic to bypass network security measures. A common example is when an attacker masquerades malicious traffic as DNS traffic, effectively bypassing existing security controls such as firewalls. And finally, domain hijacking. Malicious actors can gain control of legitimate domain names by comprising registrar accounts or using social engineering techniques. They can use these domains for phishing, distributing malware, or other malicious activities. Some mitigations for DNS security issues. In connection to DNS spoofing, you can implement DNS security extensions. Think of DNS security extensions as the digital lock and key for your DNS data. By implementing DNSSEC, you're ensuring that the information you've received from DNS is genuine and hasn't been tampered with. Furthermore, DNS response validation. It's like having a vigilant security guard at the entrance. Configure your DNS resolvers to double-check the information they receive, double-check the information they receive, discarding anything that looks suspicious or manipulated. And then there's regular DNS cache clearing. Just like cleaning your closet to get rid of clutter, periodically clear your DNS cache to remove any potential harmful entries that might have snuck in. Concerning DNS tunneling, you can implement network monitoring. Consider it as having a watchful eye on your network. You can use advanced monitoring tools and intrusion detection systems to catch any suspicious activities related to DNS tunneling. You could also implement deep packet inspection. Think of DPI as your magnifying glass for DNS traffic. Use it to closely examine DNS data for anything unusual or attempts at sneaky tunneling. You could also implement application layer gateways. These are like the detectives who inspect every package, enabling ALGs in your security devices to scrutinize DNS traffic for any irregularities that might arise or raise red flags. And then there's domain hijacking. You can implement multi-factor authentication. And just for a minute, if you were to imagine a fortress with multiple security checkpoints, by requiring multi-factor authentication for domain registrar accounts, you're adding an extra layer of protection to keep unauthorized individuals out. And then there are registrar security practices, which would be like choosing a bank with a solid vault. Opt for domain registrars known for robust security practices and a strong track record of safeguarding domain registrations. And then there's regular domain ownership verification. Think of this as checking your ID at the door. Periodically verify your domain ownership and contact details to detect any unauthorized changes, and then transfer locks. These are like padlocks on your domain. Enable domain transfer locks to prevent anyone from sneaking your domain away to another registrar. By putting these mitigations into action, organizations can significantly reduce the risks associated with DNS security issues and create a more resilient online infrastructure. It's like fortifying your digital castle, ensuring it stands strong against potential threats. As we wrap up today's exploration of DNS, its crucial role in our digital world, I want to express my gratitude for your time and attention. Your curiosity and engagement are what make these discussions truly enriching. Remember, the digital realm is a dynamic and ever-growing landscape, and our understanding of it grows stronger with each inquiry. So until our next meeting in the world of knowledge, keep exploring, stay curious, and stay secure. Until then, see you in our next adventure. Goodbye for now.